In this video, we are going to talk about how can you solve for C. Well, it turns out you can solve for C if you have something called an initial condition. An initial condition is a point that's on the graph of f of x. And notice this is a capital F of x, which means we are talking about the antiderivative. So let's look at a problem here. In matched problem 1, they're giving us the derivative of x cubed is 3x squared. A is asking us to find all antiderivatives of f of x equals 3x squared. To find an antiderivative, we are going to integrate. And we're integrating with respect to x. I'm going to put dx here. We are going to add 1 to the exponent and divide by the new exponent. And we're going to have plus c here. So that's going to give me what's called a family of curves. So if we were to think about this function, that c value shifts the parent function x cubed up and down. So if we were to graph all of these solutions are going to look like this. It's going to be your x cubed function, which goes through the origin, but it's going to shift up or down depending on what point I have on that function. And we're going to really see that when we look at part B. So in part B, they're asking us to find the antiderivative that passes specifically through the point 0, 0. They're giving us an x and a y coordinate. So we have the antiderivative of y equals x cubed plus c. We have information to plug in, and we can figure out what c is. So my antiderivative here would be y equals x cubed plus 0, which would be y equals x cubed. That would be that point, that function that goes through the origins. That's your original parent function there. But if we were to change the point to go through 0, 1, now we're going to have a different c value, substituting in to this function here. Y is 1, x is 0, and we're going to get 1 as c. So now our function is y equals x cubed plus 1. So that would be the function that is shifted up 1 unit. You can do that in a different color, which would be that guy. And then they're asking us, well, what about going through the point 0, 2? What would that do? If I go through 0, 2, 2 is my y value, 0 is still x. My c value is now 2. So I've got the equation x cubed plus 2. These are called particular equations. Or particular solutions. Whereas this is an indefinite solution. It's indefinite because we don't know what c is because you don't have enough information. But as soon as you say it has to go through a specific point, then you have a particular solution there. So that graph would be shifted up 2 units, which would look like that. C's asking, how are these related? Well, they're just vertical shifts of that original function y equals x cubed. So what if we were to change this a little bit? Let's say we have dy over dx equals 3x squared. We want to find the antiderivative. So we're still integrating with respect to x on both sides. When I integrate the derivative, I get the original function. And when I integrate 3x squared, you're still going to get the x cubed. So we're still dealing with y equals x cubed plus c in this equation. Now, you may be tempted to put constants on both sides, and that would be fine. Let me show you what would happen there. So we could say in the left-hand side, when I integrate the derivative, I get the function y plus some constant. When I integrate 3x squared, I would still get x cubed plus some constant. And I want to solve for y. So I would have a constant minus a constant, but that's still a constant. So we can still just call this x cubed plus c. Now in this example, we're going through the point 2, 6. Our goal is to figure out what c is. Substitute in everything you know. We know x is 2, y is 6. So 6 equals 8 plus c. So negative 2 is going to be your c. So thinking about all those transformations we did, we had that parent function that went through the origin. We had one that was shifted up 1 unit, one that was shifted up 2 units. And then we have this one now that's shifted down 2 units. Still going to have the same shape. It's just a different point. It's crossing that y-axis at a different point. Now let's look at a couple of word problems. In this problem, we have a revenue function, r of x. That's what we're trying to find. They're giving us the marginal revenue. Remember, marginal means derivative. So we have the derivative of the revenue function, which they're notating here. Notice the prime there. Now, they're also giving us an initial condition. They're telling us no revenue results in a production level of 0. And they're asking us, what is the revenue at a production level of 100? Excuse me, 1,000. Our first step is to figure out what the revenue equation would be. So we need to integrate both sides, and we are integrating with respect to x. So I'm going to put a dx on both sides. When I integrate the marginal revenue, I will get the revenue equation back. And we're going to have 400 minus 400x minus 0.4x squared over 2 plus c. And that can be simplified just a little bit to 400x minus 0.2x squared plus c. So there's our revenue equation. Now we've got to figure out what c is, and we can do that using the initial condition. We know the revenue is going to be 0 if we don't produce anything, so x is going to be 0. And that's going to give us a 0 for c. So our particular solution here is the revenue is going to be 400x minus 0.2x squared plus 0, which is 400x minus 0.2x squared. Now they're asking us, what's the revenue if we produce 1,000 units? So we're going to substitute in 1,000. And that's going to give us 200,000. So we would have $200,000 for revenue if we produce 1,000 units. Then let's look at one more problem. So there are 64,000 subscribers to an online fashion magazine. They're telling us that C of T is the number of subscribers expected to decrease at a rate of. And notice they're giving us a derivative here. Okay, that's because this is a rate of change equation. And they're telling us what C of T is going to represent. That represents the number of subscribers. And T is going to be time in months. We want to know how long. So we are looking for T. How long will it take for the number of subscribers on Online Fashion Magazine to drop to 46,000? They're telling us C of T is going to be equal to 46,000. And we want to know what that time is going to be. And that time is going to be given in months. So we've got a rate of change, how the number of subscribers is changing with respect to time. They've also given us an initial condition here. They're telling us that right now there are 64,000 subscribers. And I'm going to call that time 0. So right now, time 0, there are 64,000 subscribers. Our first step is to integrate our equation. We're integrating with respect to T. When I integrate the derivative, I get the original function back. I'm going to add 1 to the exponent, and I'm going to divide by the new exponent, which is the same thing as multiplying by the reciprocal. So I'm going to go ahead and just jump to that step. And then we're going to have plus C on the end that we have to figure out. So C of T, our equation that's going to tell us how many subscribers we have. It's going to be equal to negative 450 T to the 4/3 plus C. Now we've got to figure out what C is. So let's substitute in the initial condition. The initial condition says we have 64,000 subscribers right now, which would be at time 0. So 64,000 is equal to our C. So then our equation, C of T, is equal to negative 450 T to the 4/3 plus 64,000. That will tell us how many subscribers we have at any point in time. We want to know how long it's going to take to drop to 46,000 subscribers. So we're going to find T. So let's subtract 64,000 from both sides. So it's negative 18,000. And then we're going to divide by negative 450. So we're going to have T to the 4/3 is equal to 40. And then we can raise everything to the 3/4 power. We're doing that on both sides. And that's going to get T by itself. This is going to end up being T to the 1st power. And 40 to the 4/3 power is about 15.91. And that's in months. So it's going to take us about 15.91. So almost 16 months for our number of subscribers to reduce to 46,000. So if we go back and we analyze what kind of steps did we do to solve this problem. Our first step was to identify all the variables. And info, including that initial condition. And then what we did was integrate. Integrating gave us this function, which we could solve for C. So we found C. And then we had to solve, in this case, for T.